Yes, hi, this is Bernard Brault. So I'm trying to design a clock. It's going to be made out of brass, like a grandfather's clock. And this is design iteration number 6. Let me describe a little bit what's going on. The challenges I've had with the previous design. I've not even started to cut any gears so far, but I think I'm getting closer though. So what you see now is the escapement and the pendulum. So it's going to be a grandfather's clock where he's going to go click, tack, tick, tack, like sort of like every second. It's going to make a tick or a tack. So what makes the tick or the tack is when the pendulum swings, it's this escapement here. And as you can see, the escapement, I'm going to do a little bit of a simulation. But here's the tick, and a little bit later, you're going to see the tack. So as the pendulum is swinging the other way, here's the tack. So there's something else that needs to be considered here. Is of course this would stop unless there was additional amount of energy that was pushing the pendulum back and forth. And what's doing that, and I'm going to zoom in right here, is right at this moment. See, the wheel is actually turning and it's pushing that little lever right there up, and the same thing the other way around. You see, just at this moment, it's pushing this up, and it's this little push that it's giving the pendulum back and forth that is actually going to keep the pendulum going. And what is doing this is going to be, there's going to be somewhere in there's going to be a weight, and the weight, as the weight is pulling down, it's actually the weight is being reduced, but eventually this gear right here that you see, or this ratchet, is actually trying to, escape, and is trying to apply some force to the right. All right, so that's the basic principle, and I'll show you a bit later. So there's nothing new there. So let me show you the. So far, what you see here is a tick and a tack every second. So the little indicator here actually is moving. That's the second hand, right? So it's going to go do a full rotation every 60 seconds. So now let me show you how I get the minute hand, and it's basically by doing a reduction with 2 sets of gears, an 864 and an 860 right here, and what you see right there is the minute hand. So I'm going to accelerate the simulation so that you can see how it's going. So I'm going to make it a lot faster. There you go. So there's a minute, 2 minute, 3 minute, and then as you can see, the minute hand is moving accordingly. Okay, so that's what we see so far. And how do I get the I'm going to stop this. How do I get the hour hand? So I'm going to show you that. Not this guy, but this one right here, and this is what you see. So further up front here, you see a set of gears, and these gears are designed to divide this motion by 12. So every 12 rotation of the minute hand, there's going to be 1 rotation of the hour hand. One thing that will be challenging when I make this is they are concentric, and you can see that this is the wheel, the gray one here, that's actually driving the red shaft that's moving the minute hand, and you see the minute hand is held on the red shaft, versus the concentric sort of tube that slides on top of this is going to be tied to this red wheel, and that's going to be driving the hour shaft. So I'm going to show you this. Alright, so there you go, and we'll move and accelerate this. There you go. And that's what you see. So the hour hand is moving. So the next step that I want to show you is that weight that's going to go down and pull on all these gears, and that's what you're going to see right here. So there's an additional wheel, and this wheel here is going to make a turn every 8 hours. I wish it could be 12, but I cannot make a gear any bigger than 5 inch, so I'm going to have to settle for 8. And wrapped around the cylinder here is going to be a string with a weight, and that weight is going to be pulling down, and it's that pull down that actually is activating or pulling and generating the energy. So as you can see, it's a ratchet system, so it's designed so that you can wind it back up, and as you're winding the weight back up by turning this cylinder, and it's going to be like a key here to wind it back up, then you can, like, a sort of, after 8 days, rewind the string. And I did some calculation on that, and basically I'm going to use a 1mm string and 1mm wrapped around this cylinder 8 times, or every 8 hours, in order to add up to 8 days. It turns out to be like about an inch and a half in terms of length here, and the drop with this should be about 37 inches. So the weight is going to be hanging here, and it's going to drop down, and when you're going to wind it back up, well, it's going to have this ratchet, and of course there'll be a little spring attached here, and the ratchet actually is going to be attached to that spoke right there. Alright, so that's the counterweight system right there. There was one additional, so far everything's pretty standard. The additional feature that I couldn't figure out how to do, and it just, dawned on me, like, how am I going to do this, is right now if I try to adjust the time and I try to force turn the minute hand right here, and I try to turn it, well, I would be breaking down the gears. The gears are not going to want to turn if I try to push this. So what I was looking at is, how can I make, like a standard grandfather's clock, you turn the minute wheel and it just, turns, and it actually activates this, the hour hand as well. So how am I going to adjust the time? And I figured that I needed a clutch mechanism or something where if I turned this, it would activate all these gears right here, but not the back gears that are actually driving this shaft right there. So I figured I needed some kind of a clutch right here somewhere along this shaft, so that if I could disconnect this shaft from, if you want the motion works in the front versus all the gears in the back, that I could actually, force this. So I figured, how am I going to make a clutch here? And that's the next step that I'm going to show you. So I went to Fusion 360, and actually did it in the shower this morning, and I went to Fusion 360 and drew it, and it seems that it's going to work. Let me go back here. So what I'm not showing here is, of course, there's going to be a back plate holding all the pinions and the shafts, and there's going to be a front plate, and the front plate's going to be right here. So these gears are going to be in front of the front plate. Those are going to be and the back plate's going to be right. The pendulum's going to be behind the back plate, actually. So if I go to Fusion 360, here's the back plate, here's the front plate, and I'm showing the minute hand here. So let's go back here. So what I'm showing is back plate, front plate, this red minute hand shaft. Here's the minute hand, and what I'm going to concentrate on is how am I going to do the disconnect or the clutch here. So here it is. And front plate is here, the back plate is right there, and this here is the minute hand, so it goes around over an hour. And if you notice here, and let me show you this, is that I have 2 discs right there, and here's the clutch. So these 2 discs should be able to slip if I apply enough force right there, and it will decouple the shaft in the back from the shaft in the front. And I'm actually going to take this component right there and make it a little more transparent so you can see what I'm talking about. So I'm going to make it sort of 60% transparent. Yeah, there you go. So as you can see through transparency, you see that the minute hand shaft is in fact split in 2. And it's held inside of a sleeve, and the sleeve is attached to the front shaft, and it's also attached to this disc here, and the disc will slip against this one, and that's going to be the clutch. And what's going to force a little bit of pressure on the clutch is a spring that I mounted right here in the front between these two washers right there. I think I may have to figure out a way, because I'm not sure how much pressure it needs. So as opposed to try different springs, and I don't want to do this, I don't want to redesign it, so I might actually have an adjustable thread here to move the washer in and out. I haven't figured this one out. But let me show you what happens if I just move out this part right here. So if I take this part, as you can see, while the spring is sort of coming out, it wouldn't be doing this for real. But here's the sleeve, and it goes across above the shaft, and eventually will make contact, and that contact should stay there. And there's another big advantage to that is it's going to keep this shaft here, right, or this pinion needs to be kept back there. There's nothing in front of the second, or the minute hand I should say, that's holding this back. So either I was gonna like figure something else out, but the spring serves two purposes. It actually keeps this shaft in the front towards the back, and it also serves the purpose of actually creating this clutch mechanism right there. So when I actually force turn the minute hand in the front, and let me show you this. So when I'm going to force turn the minute hand, what's going to happen is that it will make the clutch slip, and only the front shaft right here will turn. And if I go back to this design, that means that, and keep in mind that the front plate will be right here somewhere, and this is all the front portion, and this is all what I'm showing right in this section here is where the clutch is going to be. So I think that should work. May have to figure out how I'm going to make this variable length, so that, you know, I want to be able to adjust the amount of pressure, because one thing I don't like about this design is when the clutch is engaged, this whole thing will act as one shaft. It's going to act like a solid piece, and this is going to turn, and it'll make the sleeve turn, make the spring turn, and of course what's going to happen is that there will be quite a bit of the washer here will turn against the plate right there, and it's going to be probably a stainless steel washer against a brass plate, so it's going to cause quite a bit of friction right there when that turns. And of course the friction there has got to be less than the friction on the discs right here, and it should be if it's smaller. I assume that, you know, the size of this may have to be a little bit bigger. But you know, that's one thing about the design that I'm not so sure is the friction on the washer right there. So there you have it, a little clutch. I don't know, it's not final. I'm gonna have to see if this is the design I'm gonna keep, and that's where we are.